Let's go to technical. It's about something technical. Give us something technical.
Database school playgrounds.
Yes. We've been
They're
talking about this for a long
working, baby.
time.
They're working,
out
baby.
there. Okay.
All right, so here's the
What happened?
situation.
Mhm.
We've got Advent of Sequel going on, which is, 15 days of adorable Christmas-themed sequel challenges, right?
Hold on. I guess that'd be that. Isn't an advent calendar supposed to be 25 days?
We do what we can.
Okay.
Yeah.
I've seen a lot of these truncated. It's not just you. I see a lot of them, and I'm always
Yeah.
like, wait a minute. I thought it was supposed to start on the 1st. What's going on here?
Yeah, I'm kind of just co-opting
Okay.
a deeply held religious belief for a little bit of marketing and shortening it down a little bit. So my
The
bad,
truncated
dog.
version. Yeah. There we go. Okay. All right.
I'm, instead of heralding the advent of the coming of Christ, I'm trying to get a few more people on my email list. So we can debate that offline. Who
Sure.
knows? But yes,
Yeah.
we're doing 15 days because
Okay.
this is the first year doing it, and I think we released Intro to Postgres like 2 weeks or a week before December 1st, and I was like, this is not going to work.
Right.
So yes, a truncated advent of sequel. As a part of this, obviously it's challenges, right? And so a big part of it is like, do the challenge, see if you can get it. Of course, we could provide downloadable, SQL that you can like run in Table Plus on your local Postgres. That's fine. I don't care. It's more fun and more useful to be able to just do it right there in the browser. And so we've talked about this architecture before. One instance where you were famously wrong. You've had a good run recently, but that one way back then, you were just like wild.
I wasn't thinking clearly back then.
No, you were off. You were off that day. You probably had a gallbladder thing going on, but you were way wrong. So as a recap, the architecture that we've settled on is the back end is just a database school platform. It's just a Laravel website. The front end is just Vue.js, inertias in the middle, all totally normal standard.
Yeah.
So what happens is on the front end, the user's, watching a video and they pause it for challenge time. They scroll down a little bit and they hit connect to database or like start database or whatever. And that's a Vue component. And it fires a request off to Laravel. Then Laravel goes out to fly.io and says, I need a new machine. And in their parlance, a machine is it's basically a micro VM. So, you could spin up a machine that's got like a gig of RAM and a vCPU, and it's like completely isolated from everything else in your system. But it's also long running, so you can keep it alive for however long you want. So it's kind of like a Lambda, but a little bit more powerful. So the Laravel app spins up a new machine, and there's some heuristics around that, which I think are very interesting, but we'll go there later. And then it comes back to the front end and says, great, I have a machine. It's been assigned to you. So in the back end, we have a table that just says like a machine, here's their IPv6 of the machine. Here's the user ID and here's the video that they're currently watching. And that's it. Like we just send back to the front end. You're good to go. You don't need to know any details about it. Have fun. Then the playground comes alive and they can type in SQL statements. And then it sends it through the Laravel application. And then on the back end, we look up the machine again, and we create a on-the-fly ad hoc Laravel database connection. So you know how you can have multiple database connections in Laravel? You can have like one for your cache and queues and one for your main application or
like
whatever.
Predefined ones you're talking about there. Yeah.
There is a DB : build that allows you to build a new database connection on the fly. That's what we do. We just build a new database connection on the fly that is has their IPv6 in it. It's actually over this private network to Fly, so their machine's not even exposed to the public internet, which is why it runs through our server. So they post to our server, we build the database connection, we run it through the private network over to Fly, run the actual commands, get the results back through Laravel, back out to the front end. They see results as if they were in Table Plus. And it works great. It's so fun. It's awesome.
Man. So now on the front end, what's it show? Like, is it like a SQL box, like just a text area and like a table?
Yeah, it looks just like Table Plus, basically, without like the table navigator area. So the top part is SQL editor with like proper syntax highlighting and all of that stuff. Bottom part is a results grid that shows the result set sent back from the query.
Interesting.
Yeah.
And it all works.
And it all works. It all works. And I had
And
a
then-
few hiccups,
Okay.
which we can talk about around machine reservation, but you were going to say something.
Yeah, I was, but now I can't remember what it was. Oh, how do you kill them off? Like just
Okay,
after a
great.
certain
So we'll do the
time
whole life
period?
cycle then. So
Okay.
every video on the back end, I have a couple of base Docker images, Postgres 17 being the relevant one for this conversation. So I have a Postgres 17 Docker file on the back end. Excuse me. In our Filament admin panel, I can go in and say like, hey, I need a new Docker image. We're going to start with the Postgres 17 Docker file that's defined in our code base. And then on top of that, I want to layer this SQL file that's, like 40 megs or 50 megs of like SQL statements to insert all this data. So I have the Docker file, the data, and then on our backend, we can hit build image, and that bakes all of that together into one Docker image, and that pushes it up to the Fly registry. So then on the back end, it spawns a Laravel job that's like, hey, take these two things, put them together, use the Fly CLI to create a Docker image, and then give me the tag for that Docker image. So then in our back end, we see like, these named Docker images. It's like Advent of SQL days 1 through 3, Advent of SQL's day 4 through 7, or whatever. Then we can assign Docker images to videos and say like, this video requires this Docker image. And inside that Docker image, of course, is all the data that supports that video. Now, when the backend sees, our backend sees that a Docker image is assigned to a video, we have a set of heuristics to build up a pool of machines. So machines come from Docker images. So we have a heuristic to build up a pool of machines. Now there are two states in Fly that are basically stopped states. One is truly stopped. This machine is like stopped, and a cold start could take many, many, many seconds. The other is suspended, which costs a little bit more, but a cold start could take 200 milliseconds.
Oh, wow.
And so what we do is we build up a pool of suspended machines. So for any given Docker image, we'll have 4 to 5 suspended machines. And it could take a minute and a half to create a machine, because you have to create it. Postgres has to start. You have to run, thousands of these insert statements, and then finally it's ready to receive connections. So in the back end, we start up all these machines and then we suspend them. So then when a user goes to claim a machine, they claim out of the suspension pool, and they just get a machine in 200 milliseconds, and they're ready to go. And then in the back end, we have a balance heuristic that says, oh, we're running a little low on suspended machines for this image. Let's create some new ones. Now, the way that we kill machines is one, a user can request a new one. So like if they just totally dork everything up, they can hit reset database and it just drops it out of the pool. The other is we fire heartbeats from the front end. So we fire a heartbeat like every 10 seconds. And on the machine record in Laravel, we store when the last heartbeat was. And if we haven't heard a heartbeat in, I forget what it is, 15 minutes or something, we assume they've navigated away. They're not using this one. And we put the machine into stopped state and then destroyed state. So once a machine is stopped, we never reuse it because that contains prior session data, which isn't like I don't care. It's just, it would be confusing if they loaded it up and somebody mucked around with the data. So once it goes into a stopped state, it then finally transitions to a destroyed state. And that's the whole life cycle. So we have the pooling, the balancing, the claiming, and then the stopped, and then the destruction. How about that, Ian?
That's
still
pretty
technical,
good.
baby. Still
it's
technical.
Pretty good. He still got it. You don't have this on the homepage though. I looked.
I know.
Where's
I know.
You gotta update the marketing. This is like
I know.
a cool little gizmo.
This is cool.
That's fairly unique. I don't know if anybody else is doing this or not. Many other people are doing it. So yeah, I like this.
It's fun, right?
Yeah, it is fun. I'm with you. And it's gonna be good. You can do the Redis, you can do the other stuff, whatever. I like that that you're already utilizing it with like the advent of SQL is pretty interesting. Like you'll be able to leverage this in other ways besides just like the big courses and stuff. So you can always, even when you make one-off videos and things, it won't be too big a deal.
Totally.
I mean, the advent of AI is going to make making the fake data for these courses so much nicer, I assume.
It really is,
yeah, rather than having to like just spending time making up data, which is realistic.
Always been a surprisingly hard part is like
Yeah, it really
coming up with the
is.
sample data to teach the actual thing.
Yes.
Surprisingly
Yeah.
difficult.